Welcome back, guys. We are continuing on with basic probability. This is the part 2. And so going on to the next page, we're on 118, just continuing from last video. Probability using counting techniques. So the counting techniques we learned about yesterday, which is like using combinations and permutations, can also be used to solve problems from the previous page. Most students favor one method over the other, so understand both and pick the method that you like the most. So what we're going to do is we're going to answer those same block problems, but using combinations. And I have it like pretty structured out where it kind of like helps guide you guys through it. Just to be perfectly honest, I prefer solving it this way, like using fraction, percentages, and probabilities. I don't think the combinations really comes naturally to me. Some people really like it this way though, so I wanted to give you guys the ability to choose which method you want. So, number 1, what is the probability of selecting 2 red blocks without replacement? So there are 7 choose 2 ways to select 2 blocks from the bag. There are 3 choose 2 ways to choose 2 of the 3 red blocks. So we could put that as a fraction. 3 choose 2 and 7 choose 2. I'm going to pull up my calculator real quick. So just a reminder how you can pull that up on your calculator if you need a quick refresher. You do 3, this is the old one, and I have to put the first number first, and then do math, arrow over to probability, and go down to NCR. Press enter. So I've already chosen my 3 as my N, and then the 2 will then count as my R because it's the number closer to there. So that numerator is 3. And then what's really nice is I can do second enter, which pulls back the very last entry, and I can go back and retype over that rather than having to type it all a second time. So then your fraction simplifies to 1/7. And just to clarify, this is the same problem as before, just solving it a different way. Some people really like it, some people don't so much, so you can do it whichever way you want. Number 2, what is the probability of selecting a green block and then a red block with replacement? So notice previously it was without replacement, so just keeping in mind the differences. So what changes in our steps when we replace blocks? What's the difference between number 1 and number 2? So notice the first one, we were just picking 2 blocks and not replacing them. So we were able to do both blocks in one motion, whereas this one, because you are putting them back, you can't do it in one motion per se. So we're going to have one fraction and then another fraction. So what we'll have to think about is for each of them, we have 7 total and we're choosing 1 would be your total ways it could happen. And on the top, we have, we want 1 red block and 1 green block. So there are 4 green blocks, so 4 choose 1. There's 3 red, so 3 choose 1. This simplifies to 4 out of 7 times 3 out of 7, which I really prefer seeing it that way, just thinking about it like we did on the previous page. For my brain, it makes more sense for me. It simplifies to 12 out of 49. So this part here is more so the last page way of thinking about it. Last one with this way of thinking is what is the probability of selecting 3 blocks of the same color without replacement? So we are not replacing them. We want to think through the number of ways to choose 3 red blocks or, right, choose 3 green blocks. So remember when we do or, we want to be adding our 2 fractions, right? Thinking back to the Halloween candy, you add how many Snickers and how many Milky Ways if you want the probability that you'll pick either candy. So we have a total of 7 blocks and we want to choose 3 of them, right? 7 choose 3 because we're trying to figure out what are the chances we pick all 3 of the same color. So let's do this one is maybe all red. And then we'll do this one is all green, just to make it a little easier. So for the all red one, there are a total of, I believe, 3 red blocks. Yes, so sorry, just needed to double check that I got the right number. So there are 3 red ones, and we are choosing all 3 of them. Whereas for the green one, there are 4 green ones, and we're choosing 3 of the 4. These fractions are going to simplify. I'm just going to kind of tell you what they simplify to make it a little bit easier. They simplify to 1 out of 35 plus 4 choose 3 is going to be 4 out of 35, which will simplify to 5/35 or 1/7. And me personally, I prefer to think of it the other way, but some of you guys might see this a little bit more naturally. So the next page, this is kind of going in a different direction. So you can kind of put this in the back of your mind. You don't need it anymore. This is just some card problems to practice replacement, right? Do you put the card back? Do you not put it back? So kind of going back to what we were thinking of on this page where we had to think through, is the bottom changing at all with our fractions? Am I going down in how many total cards, or am I having the same amount of cards? And this relies on some knowledge of playing cards. So playing cards have 52 cards in a deck. There are 4 suits. There are spades, which I'm a terrible drawer for that. I've never been able to draw spades well, but they kind of look like an upside down heart. There are spades, there are clubs, which looks like a 4-leaf clover. There are hearts, and there are diamonds. And then there are 13 cards of each suit. So there are 13 cards, or a fourth of the cards that are each type. And for each of them, you have an ace, 2, 3, 4, 5, all the way to a king. Okay, so there are 13 of each going through all the types. What I want you guys to do is try these ones out. Do as many as you want. These are just some extra practice problems just to make sure you're feeling good on replacing. Okay, so I'll walk you through it. You can pause the video if you want to try them on your own as well. Okay, so probability of selecting an ace. Total aces, total cards. There are 4 aces out of 52. That can simplify a little bit. Oops, sorry, that should be a 26. There we go. So that can simplify a little bit, and then once more to a 13th. And then the probability of selecting a heart, so heart and then a club. And we are told that this is with replacement, so I am putting it back, which means each time there will be 52 total cards. So the total hearts, remember it's a fourth of the deck, so 13. If I'm putting it back, there's still 13 cards. So that would be the setup, and then you would multiply from there. And then the last one is, what is the probability of getting 2 aces without replacement? So that means I go from 52 down to 51. And 2 aces in a row, there are only 4 aces to begin with, so it'll be a 52 times 3 over 51. Okay, and then your simplified answers. I'm just going to calculate it on my calculator real quick. First one simplifies to a 16th. Second one simplifies to 1 over 221. Okay, so that is the end. The next page is just practice problems that we're going to go over tomorrow. The next topic that we're going to talk about is compound events. So this will be the next big focus video. Casework, I'm probably going to leave it up to you guys if we want to work on it in class. If we have some extra time, we can go over the casework and try them out. But I just don't want to give you guys too many videos to watch tonight. So I'm probably just going to do the first 2 and have the casework just be some extra practice problems that we might get to in class if we have some extra time. Okay, so the only one that you'll have to do next is compound events and counting, which starts on page 123. Okay, so I'll see you guys in the next video.